What's Isaac? Oh, there we go.
All right, help me out on these OGT problems. We're just going to go over them real quickly. I'm not going to collect it this time. So somebody tell me what was the first one? Week what? Question what?
Week 8, number 6.
Week 8, number 6. Follow along, we're going to go over them very, very quickly. Notice that when I assign some of these OGT questions, the stuff that we're going over here in the last few days? Yes. So that's the reason that I'm assigning, or that we go over them. Number 6. Which pair of equations represents lines that are parallel and perpendicular to the line y equals negative 1/3 x plus 3. This is week 8, problem number 6. If a line's parallel to this line, so if you got a line that's parallel, first, what's the slope of the original line here? What's m in this original line? Very good, negative 1/3. We will have a test coming up here real soon, so make sure you're understanding this stuff, follow along. If a line's parallel to that, what do you know about the new line's slope? It's got to be the same.
Parallel.
If it's parallel. If it's perpendicular, somebody started to say it.
Opposite reciprocal.
Opposite reciprocal. What's the opposite reciprocal of negative 1/3? 3 over 1, or just 3. So what we're looking for, and it was a multiple choice question, so what we're looking for is our lines, and I know that there's a couple of problems like this on the test. The bad thing on the test is the problems are a little more difficult, because I think instead of them giving you the equations in slope-intercept form, I think all the equations are in standard form, and it's harder to tell what the slope is when it's in standard form. You've got to actually do a little math. A, B, C, or D, which one has one line that has a slope of negative 1/3 and the other line that has a slope of 3? Okay, everybody agree with that? That makes sense to everybody? Do we have to write out the whole equation and everything for both those other two lines? No, we don't. All we need to know is that first part, one of the lines should look like this. Don't really care what's out there. The other one, the other equation should look like this. Don't really care what's out there. All we care is that this one's parallel to the original line. This one's perpendicular to that original line. Next one was the next question. Week 11, number 2. They say which numbered angles are supplementary to angle 6 if L and M are parallel. So we know that these two lines are parallel to each other. And we want all the angles that are supplementary to angle 6. So the easiest one is which one? We have angle 6 here. 4. I accept that. How do you know 4 is supplementary to it? What kind of angles are they? Consecutive, interior. And that's the only ones out of all the pairs that we learned about, that's the only ones that have to be supplementary. So angle 4 is one of them. Angle 5, somebody said, how do you know angle 5 and angle 6 are supplementary? They form a line. Give me another.
One.
Angle 8, because again, 6 and 8, they form a line.
One.
The other one is 1. How do you know angle 6 and angle 1?
Because when you switch the lines together, they form a line.
Okay, so probably, maybe you know that these two are supplementary. Well, what do you know about angle 1 and angle 4? They're vertical angles, they have to be the same, so if these two add up to 180, then 6 and 1 also have to add up to 180. Lots of different ways you could do that. Is that one of the answers on there? 4, 5, 8, and 1? D? Name me all the angles in this picture that are congruent to angle 5. 8, that's 1. 1, 4. Is that all of them? All right, you should be able to do that. You know, you can pick out vertical angles, alternate interior angles, corresponding angles, all that stuff, and say, all right, I know all these angles are the same. All these angles have to be supplementary to those other angles. What's the next one? Week what?
15.
Number 1. This is like an extended response question, right? 15, number 1. Just a second, draw the graph up here real quick. Again, don't go by what my picture looks like. You're not supposed to know what a parallelogram is quite yet, because we haven't got that far in our book. But we will. Anybody tell me what a parallelogram is?
A shape with, or a quadrilateral with four, or 2 different parallel sides.
All right. Quadrilateral where opposite sides, both pairs of opposite sides are parallel to each other. My shape probably doesn't look real good. We'll see. That's not fast. Now, this is what they want you to do, and I've seen this problem or a problem like this on the OGT many, many times. This is probably a 4-point problem. So when you're doing these 4-point problems, you got to do all the stuff that they ask you to do to get all 4 points. First thing I'm going to do is, if this is a parallelogram, what do we know about AB and CD? They should have the same slope. So I'm going to go over here, and I'm going to find the slope of line AB, and I'm going to find the slope of line CD. How do we find the slopes again?
Y equals mx plus b. No.
What's the slope formula? Rise over run. Slope formula, you subtract the y's on top, subtract the x's on bottom. So, Peyton, what's my y coordinates for A and B?
The Y, -9.
Now be careful. Peyton likes to do everything, make it hard on everybody else. So
1
Weston.
-6.
Weston. Peyton took his this way for the y's. What's the x's for A and B?
-4 minus -3.
Peyton can't fool you, can
I did mine like that too.
he? So you and Peyton think alike.
You guys can be, I thought that's how you're supposed to do it. You guys can be weird.
It doesn't.
You do it like that.
Well, you can do it this way, like you guys did, going this one first, then that one, this one first, then that one. Or you could go this one, then that. It doesn't matter. I'm just kidding.
You just have to go the same one.
You just have to, wherever you start at, wherever this one came from, that one has to come from the same point. -3 minus 1. Emma, what's -3 minus 1? Close. Go the other direction. Here we can switch those. Hopefully you can read my writing there. Robert, what's -4 plus 3? What's a negative over a negative? Positive. So slope there is just 4. You don't really have to reduce it down. Did we do something wrong here?
Probably.
-3 minus
Well,
1.
it's going up the right direction, it should be
Okay, that's-
positive.
Okay.
Maybe.
CD. Austin, what's the y coordinates for C and D?
3, -1.
Uh-oh. So be careful. Austin decided to go the other way. He wanted to be different than Peyton and Weston. So, Ryan, what's the x coordinates for C and D? Up on top, 3 plus 1 is what, Brittany? You gotta do another one because that one was too easy. 3 minus 2?
Braden's messing with it.
Right, you better quit messing up people. Alright, now watch, because this is where most of you mess up on the OGT, and you don't get full credit. Just like in this class, and what we're going to do today especially, you show this to them. Does that person looking at grading your test have any idea what that means? No. We say, alright, the slopes, what do we know about these slopes? They're the same. So what's that tell us? Lines are parallel. And that's what we write. Slopes are equal. So lines are parallel. Probably if I'm doing this on the OGT, I wouldn't abbreviate like I do. Because who knows if they know the symbols, or whoever's grading it knows all the same symbols that this book teaches you. Now, is that enough to say this is a parallelogram?
No. Other 2 sides.
Other 2 sides. What are the other 2 sides?
BC.
BC. So we're going to find the slope of line BC. Now, everybody understands when I put line BC, does it matter if I call that a line, a segment, or whatever, if I'm finding the slope?
No.
No. Now, but if I was trying to find the length of it,
Yes.
then it'd matter. I wouldn't want to call it a what?
Line.
I wouldn't want to call it a line. I'd want it to be a segment. What's the other line? Faith, what's the y coordinates for A, or for BC, sorry?
3 minus 1.
Make sure you go in the same order she went in. Josh, what's the x coordinates for BC?
-3.
Bottom, we can change those signs. 3 minus 1. Carson, what's 3 minus 1? You gotta do another one, Carson. 3 plus 3.
10.
1/3.
2 over 6 reduces to 1/3.
Your math ladies.
Next one for A and D. Brighton, what's the y coordinates for A and D?
-1 minus -3.
X coordinates. Nick, what's the x coordinates for A and D?
2 and -4. That's wrong.
Brighton confused me when I thought he was telling me the truth when he said you were wrong. Should have known better. Change those signs. -1 plus 3. Robert, what's -1 plus 3? 2.
Thanks, Robert. Good job, Robert.
2 plus 4.
6 is 6.
6. What's that reduced to?
1/3.
Oh,
It's a parallelogram.
What's that tell us?
They're the same.
parallel.
Slopes are equal to line.
Their slopes are equal.
Make sure you write it out again. Slopes are equal. So lines are parallel. Now, is that enough?
We have to say that it's a parallelogram.
Exactly. If you did all this work right here and it was worth 4 points, you get 3 of the 4. Because you got to give that last thing, summing everything up. Just like we did in the paragraph proofs or the 2-column proofs. You got to give reasons, like we're doing here. Then you got to come over here and you're going to say, since both pairs of opposite sides are parallel, it is a what?
It is a parallelogram.
It's a parallelogram.
If it is a parallelogram, then it must
It doesn't like when I write that much. Yes, Brian?
On the OGT, if they give you a little picture and you were just like, boop, 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 boop,
Right. So,
think about you.
no. So if you wanted to use the diagram, which they did give you a diagram here, right? We didn't really have to do all this work. You could have in your diagram, you could have just done this, say, all right, I went up that many, and I went over that many, but I would have done something like this then, say up and over, and put m equals 4 over 1, or whatever it was. So Brian, if you were going to do that, show that, come over here, do that, show that that one's 4 over 1, then still say, since these slopes are the same, the lines are parallel. You just wouldn't have to done all this work and all that work. So yeah, that's a good point. If just going back through this, if you showed, let's just say you showed these 2 slopes and these 2 slopes, and you thought you were done, you'd probably get 1 point. All right, maybe 2. I'm not sure how they would do that. You show the slopes, so if Brian just came in here and did this on his picture, I know you wouldn't do this, Brian. He wrote this, and then he wrote, so it's a parallelogram, you might get 2 points. You're going to get half credit, 50%. All right? You still got to give some kind of explanation what those slopes tell you, because that's what they want you to know, is what the rules are. Not, you know, they want to make sure that you know, hey, if opposite sides are parallel, then it's a parallelogram. And they want you to know if the slopes are the same, then the lines are parallel. They want you to know those rules, not just how to do the math. Questions on 148? Remember, we are going to take a quiz here in a minute, so.
Don't answer any questions.
16? Is that what you said, Brian?
Yeah.
Number 16.
Oh my god.
Did you get number 1 wrong?
Says, write equation slope-intercept formula line having a given slope and y-intercept. Is this a y-intercept?
Yeah.
What is the y-intercept then?
8.
8. So, because that's 0, b is 8. What's my equation then?
That was like the whole, like.
We still get that wrong.
All you had to do is put in X.
Excellent, all right, Nate.
No, I was gonna ask, like, what if instead of 0 it was like 2 there? What would we do?
See if we can find one down through here.
I'll tell you what, let's do 22. 22 said write it in point slope form, right? But let's write it in slope intercept form. I'm going to show you 2 different ways you could do it. M equals -5, and then they give us a 0.47. So we got this line. It goes through the 0.47 and has a slope of -5. Couple different ways you could do this if you wanted to write it in slope intercept. Now they said write it in point slope. So over here, I'm I'm gonna write down the actual answer to 22 in point slope form. All you do is y minus the y coordinate, which is 7, equals -5 times x minus the x coordinate, which is 4. That's the actual answer that they wanted for 22. Now I'm going to change the directions and say, no, we want it in slope-intercept form. So if I'm going to write it in slope-intercept form, a couple things I can do here. Because that's not my y-intercept, because it's not 0 there. You could have it in this form, distribute. Now I'm just doing this very, very quickly. Move the 7 to the other side by adding 7. Is that in slope-intercept form? Yeah, so you could do that. Distribute, then add 7 to both sides. And that would get it in slope-intercept form. It's not too difficult, depending on if you have a bunch of fractions in there or not. The other thing you could do is you could, and I sort of don't like showing everybody this way because it's easy, and hopefully most of you guys will be able to understand it, but it confuses a lot of people. If I have all of this is my slope-intercept form, and I know these 3 numbers, I can plug in here, here, and here. What's the only variable left there then? And we can solve for B. What I plug in right here, just like what you plug in down here, I plug in the y coordinate. 7 equals -5 times the x coordinate. So all I did was plug in those 3 spots, and that's going to allow me to figure out what B is, what the y-intercept is. -5 times 4 is -20. Any of you remember this from last year? Yeah, no, maybe. And I don't know, maybe Mr. Harrison, a lot of algebra teachers don't even really spend a whole lot of time on point slope form.
Yeah, we didn't really spend much time.
On that. So you probably did this a lot more than this. See, I do it the other way around. I do this a lot more point slope because I think, all right, if I can teach you how to write it in point slope form, then you should be able to change it algebraically into the other 2 forms. But this is just as easy. Add 20 to both sides. You end up with B equals 27. So now I know B is 27, M is -5. This is the part that I think is confusing to a lot of students. Because now we got to go back and plug back into that y equals mx plus b form. But this time, where do we plug in at? The B and the... All right, M and B is all we plug in this time. If you're looking for B, you got to plug into all 3 of those spots. When you're trying to write the equation, you just got to plug into those 2 spots, once you know what B is. So our equation would be y equals -5, x plus 27. That same thing we got doing it just another way. So there are several different ways you can, do a lot of this. That confuse everybody? Josh, that confuse you? You don't know?
I'm not feeling much of anything right now, just...
Other questions?
What's going in there?
Go ahead, Dave.
50.
50?
I heard you.
Write an equation in slope-intercept form that models the county line between Jeff Davis and Reeves County. It's got great big numbers on it, doesn't it?
It's only like half of text stuff.
Jeff Davis and Reeves county. So 130,
I bet it's safe to know what
negative
it is.
70,
And then off from there to the pump it.
120, 60. What two things do we have to know to write an equation for a line? They said write this one in slope-intercept form, right?
One equation is supposed to be
So we want it y equals mx plus b. What two things do we need to know?
Slope and line.
Slope and y-intercept. Well, I can find the slope by using the slope formula. Help me out again. What's my y coordinates? Austin, what's my y coordinates?
Negative 70, 96.
Brittany, what's my x coordinates? Negative 70 plus 60. Robert, what's negative 70 plus 60?
Negative 10.
130 minus 120. Brighton, what's 130 minus 120? Negative 10 divided by 10. Nick, what's negative 10 divided by 10? Close. There you go. So now we know the slope is negative 1. The only other thing we need to find is the y-intercept. Well, you could just pick one of these points and write it in point slope form. So y minus y1 equals m times x minus x1, and then change that into slope-intercept form. Or you could go through what we just did a second ago and find the b by picking a point. I'll pick the first one since I already circled it, and just plug it in here, here, and here. And that's going to allow us to find the b. So there I plug in negative 70 for the y. Our slope is negative 1. Our x is 130. What's negative 1 times 130? Carson, how do I solve for b?
You will.
How do you get b by itself?
We have to add 130.
They were probably all confusing you, weren't they? Negative 70 and positive 130. What's that give us? 60. Do I have enough now to write this in slope-intercept form? So what's it going to be? Negative 1x or negative x plus 60. So that's the equation for that county line.
Oh,
Now, if I could have stopped right here instead of going through this over here. And again, it's up to you, whichever way you do it. Could have picked a point, wrote it in point slope form. It'd be plus 70 equals negative 1 times x minus 130. The only problem with that is you write it in point slope form, then they wanted it in slope intercept, so then you got to change it over. We do that by distributing. Then we got to subtract 70 on both sides. So you end up with y equals negative 1x plus 60. That same thing we got doing it the other way? Yeah. Look at our county line. Does our county line, does it go down from the left to the right? In the book, does it go down? So it should have a negative slope, so we look all right. All right, 51. Somebody help me out. What was the equation that we just had on the last one? All right, so this was, you got these two county lines. Don't want to just draw some crazy picture without. That's the one that we just got done finding the equation for. You got another one that comes in right here. And they say that we want that to be a right angle. Well, the coordinates of that point, what were the coordinates of that point? Is that the 120? 120, negative 60. Oops. 120, negative 60. If we're trying to write an equation that's going to form a right angle there, so it's going to be perpendicular, what's the slope of this new line going to be? If this line right here had a slope of -1, what's the slope of this line got to be for that to form a right angle?
Negative.
It's the opposite reciprocal, right? So what's the opposite reciprocal of -1? +1. Don't make it hard. +1. We still need to find the b. Let's see. Well, I might be lazy this time. Right, and equate. Oh no, they said slope-intercept form again. So we could use this. Y equals mx plus b. In place of y, we could stick in that number, -60. In place of m, we're going to stick in 1 this time. In place of x, 120. That's going to allow us to find b. It's 120 plus b. How do I get b by itself then? Subtract 120. What's that leave us with? What's my equation then? And again, I could have took this point and the slope and written it in point slope form, then changed that over to slope intercept form. Doesn't make any difference, whichever way you decide to do it.
On the paper that we did the OGT on.
Yeah, you could. Just make sure you mark out the OGT stuff and make sure I know where the quiz is at.
This forever saw that was my jam going on
So
there.
maybe I'll turn it back on here in a minute if I get done explaining. On this quiz, you only got about 6 or 7 minutes to do it. When you get finished, lay it on the blue chair. It's not real hard. You can work with a partner. The quiz isn't easy, so even if you don't get up to go work with a partner, Robert looks over and he says, "Hey, Brittany, how'd you get number 6 there?" I'm not going to throw a fit. All right? Now, do I want all of you turning in papers that all have the same answers on it? No, I don't want that, but what if they're all right?
Deep down.
You know, if they're all right, then I guess that'd be a good thing. But I don't want everybody coming up here to Brittany and saying, "Hey, Brittany, let me see your paper." And everybody standing around their desk copying down all of our answers just so you can get them all right. No, they don't even like each other in there. So. I shouldn't say that. All right, on this quiz, watch.
Oh, yeah.
First one, find what you had to do, find the slope of AB, slope of CD. Slope of AB was 4/1, slope of CD ended up being -1/4. If those are your two slopes, what's that tell you about the two lines? They're perpendicular to each other because they're opposite reciprocals. Next one, slope of Q, you could count it on the graph. It was 1/2. So what's the slope of a line that's parallel to that? 1/2. Next one. Figure out that the slope is 1/2. I think that was line Q again, wasn't it? Line Q slope was 1/2. The y-intercept was 2. They wanted us to write an equation for that. So y equals mx plus b form. We just stick in the m and the b and get y equals 1/2 x plus 2. Next, Josh, you taking down all my answers?
Yeah.
I didn't realize you still had your quiz. What you yelled at you?
All I did was just write my name.
Alright.
That was counselor.
Slope of P is 7/2. Brighton asked a good question.
What?
If you want to change that to 3.5, anytime it's slope, you want to leave it as a fraction, because what's slope again? Rise over run. So that tells you the rise and the run. They wanted a line that was perpendicular to that, so you got to do the opposite reciprocal. -2/7. And they told you it went through the point 0, 0, I think. So that means the y-intercept is 0. And I would accept if you wrote it this way and left the +0 on there, that's fine. If you didn't leave the +0 on there because it's unnecessary, then it'd just be y equals -2/7 times x. The last one, they tried to confuse you on the last one. The original line was a horizontal line. What's the only kind of line that's going to be parallel or perpendicular to a horizontal line? A vertical line, right? So it had to be a vertical line. What do you know about the equation of any vertical line? It's always just... Of course, my thing had picked that point to mess up. It's always just going to be x equals some number, right? Well, they gave you, what point? They gave you the point -4, or something like that?
Yeah.
All you got to do when you know a point that falls on a vertical or horizontal line is look at the x or the y. If we're looking for a vertical line, we know it's x equals something, then we look at the x coordinate, and that's what x is going to equal. X equals that number. So that means x is -4 on every point on that vertical line. What if they told us...
Odds for extra credit? For redemption or something? Come on.
What if we were going to write
No.
an equation of a horizontal line that goes through that point? It'd be y equals what? Horizontal line. Just look at the y coordinate. Y equals -4.
You should have understood the odds and then the
Today is the 11th. We got to hurry. We only got 12 minutes. All right, so what we're going to do, we're going to prove lines are parallel using theorems and postulates. All this is going to be, every theorem and postulate that we covered today except for one, is the converse of the theorems and postulates that we did earlier. So, one of the postulates that we did earlier, one of the postulates we did earlier said this: if you have parallel lines, or if lines are parallel, then corresponding angles are what? What's the magic word?
What am I saying? Congruent.
Congruent.
Yeah.
What's the converse of that statement?
If corresponding angles are congruent.
If corresponding angles congruent, then lines are parallel. So now instead of them giving us a picture with a transversal going through there, instead of them telling us these two lines are parallel, they're going to say something like this. This angle is 70 degrees. This angle is 70 degrees. Well, what kind of angles are those two to each other? Corresponding angles. If those corresponding angles are congruent, then guess what we can say about these two lines? They're parallel to each other. So it's just going the reverse of what we did before. All right, write these down. I'm going to add...
He's on a roll today.
I'll write something in here. I got to remember what the parallel postulate says.
Left and right, we don't got time, guys.
that song, so I'm stuck in my head all day.
On that one, on 3.5, when you get to it, it's called the parallel postulate. All it says, if I have a line here and a point right here, and I make Emma come up and draw a line through that point that's parallel to the original line, and then I make Weston come up and do the same thing in a different color, then I make Faith come up and do the same thing in a different color. Is there going to be, how many lines are going to be up there? One. Because how many lines that go through this point that are parallel to this one are there in our world? There's only one. So, that's all they're saying. Remember when we did the crook problems? We had these two lines and you had that crook through here and you had to draw a line through there? This is what allowed us to do that. Because there's only one line that's possible to be drawn through that point that's going to be parallel to the other. So that's what this allows you to do. Draw a line. It allows you to add a line to a picture when you're saying, all right, I got this point and I have this line and I want another line that's parallel to the original line through that point. All of the rest of these, notice they're just backwards of what we covered before. Everybody see this last one? So the first one says if corresponding angles are congruent, then the lines are parallel. And for some reason, they turned them around on us. This one says if alternate exterior angles are congruent, then the lines have to be parallel. This one, this is the, remember 3-6 here is the one that is different than all the rest of them because it deals with consecutive interior angles. Consecutive interior angles aren't congruent to each other, they are supplementary. Then the lines are parallel. And if alternate interior angles are congruent, then the lines are parallel. And this last one, this says if you have these two lines and they're perpendicular, so they form right angles, with that one line, then what do we know about the two lines here? They have to be parallel to each other. Too difficult, Corbin? It's just reversing everything that we did a couple of sections ago. All right, so don't make
I'll
it.
probably go too fast though and mess it all up, like I always do. I can just see it happening.
Right here. Faith in you.
When you're doing these problems, because I won't be able to,
Jesus.
we were going to do a bunch of them together, but we're probably not going to have that much time. When you're doing them, they give you a picture. Maybe your picture looks like this. I'm going to use this right here since I already got it up here. And they tell you that's angle 1, that's angle 2 maybe. And they tell us angle 1 is congruent to angle 2. Maybe this is line L, this is line P. What do we know about line L and line P then? They're parallel, so this is what we write. L is parallel to P, and then you've got to give a reason. Which one of these is going to be our reason for those two lines being parallel?
Alternate interior angles are congruent. 3+.
And do not write what Robert just said. Write if
What did I say?
alternate interior angles congruent, then we know that we have parallel lines.
What did I say?
Said 3.7. Well, that was Brian. So, again, don't write 3.7 or 3.8 or 3.5 because I don't have any clue what any of those say. All right? All right, so this is your assignment, page 155, 13, 31, 34, 37, 40, 42, 45, and 46.
It'll be on.
There.
In page 250, 1 through 9 odds.
The time I said that.
For
Or
redemption,
it wasn't
You
on.
notice the dance moves.
for redemption from Bryant, from
That's
the
how it is.
2 through 10 even. Right? Josh, get your sassy mouth.